All right, let's concentrate on Product Design Suite. So again, this is a suite of products by Autodesk. And what it's meant to do is design, visualize, simulate, and then manage all the things that you would need to do in workflows all around designing a vacuum cleaner, a blender, or a car. So it's discrete manufacturing. It's heavy on Inventor, the 3D solid modeler, so I'll cover that separately, actually going through Product Design Suite. But most everything is circled around Inventor, and you can, again, visualize, simulate, and manage, but the design is done in a product called Inventor, and I'll go through that. All right, who buys this stuff? Actually, business leaders, looking at really getting an advantage and controlling costs. It's easy to implement, especially in global, so IT managers like it. But what I'm going to focus on is us, the engineers and designers. So how do we streamline product design? How do we get it done quickly? Is it easy or not? And can we get all those files out to sales and marketing and get all the customer requests that want it done? And that actually is contained in the product suite, Product Design Suite. Sorry about that. And again, also I'm going on 2014, the latest release. So what I'm going to focus on is this process within. So conceptually, how do you do it? How do you get started? And that's in Sketchbook Pro. So that's part of the software that we'll be looking at today in a short demonstration. And then engineering, done in Inventor. How do I draw it, solid model, get the weights and all the balances and stuff? How do I, once I have the information, how do I simulate it? Can I get data out of it? What's going to break? How's it going to function? Do I need to make something stronger, or can I take some weight out? And then document it. How do I get it down to the shop floor and all the other people, suppliers are going to help me? And then last but not least is visualize. So that's something that's being widely used, very, very strong point with Product Design Suite. So it is high-end rendering packages to get all the lighting and realism that you would need. It actually is photorealistic. So again, the art departments of Ford, GM, and Chrysler all use it. Actually, they're standardized on it. All right, we're going to look at a quick video here. I won't talk over it. It has words, and this is an overview, actually, of what Product Design Suite offers. I'll go ahead and get that started.
Autodesk Product Design Suite is a comprehensive solution for digital prototyping, delivering design, visualization, and simulation tools. You can complete your entire engineering design process with one economical and convenient package. Drive innovation with integrated, discipline-specific tools built for digital prototyping and based on Autodesk Inventor software. Explore design concepts and produce stunning illustrations with software that enables you to paint and draw in the industry's ultimate digital sketchbook. Speed documentation, sharing of ideas, and exploration of concepts with powerful design and documentation functionality found in AutoCAD software. Quickly transform your AutoCAD and Autodesk Inventor data into compelling imagery, movies, and interactive presentations to improve the design review process and secure internal buy-in. Autodesk Product Design Suite provides an advanced 3D design and drafting solution complete with electrical engineering, routed systems, and tooling. Autodesk Inventor, innovative 3D mechanical design software, also comes complete with tools for designing routed systems, including complex tube and pipe runs, and electrical cable and harness components. Develop and evaluate engineering concepts more quickly and easily with integrated tools built specifically for design and visualization. Incorporate complete electrical and mechanical designs within a single comprehensive workflow. Decrease development times, increase product reliability, and reduce change orders with integrated analysis tools to engineer and validate your designs. With the powerful design and simulation tools in Autodesk Product Design Suite, you can better predict how the design will perform under real-world conditions before the product is ever built. Create engineering documentation and gain more control over your design data with Autodesk data management software that can help you manage the design creation and documentation processes. Autodesk Product Design Suite securely stores and manages information in a central location, so your team can quickly create, share, and reuse digital prototyping information. to better market and sell your products, create cinematic quality renderings and 3D animations directly from your engineering design data, reducing the need for costly physical prototypes and photo shoots. Autodesk Product Design Suite is a comprehensive solution for digital prototyping, delivering 3D design, visualization, and simulation tools to complete your entire engineering process. The digital prototyping capabilities of Autodesk Product Design Suite can help you design better products, reduce development times, and get to market faster.
Okay, so hopefully that'll bring up some questions. And one of the things when people watch that video, the next thing is well, what all comes in this package? So it does come in 3 flavors, standard, premium, and ultimate. Basically everything I'm designing here is ultimate because by far that is the largest seller. And that comes with all the 3D visualization and also the analysis tools. So you can check Autodesk website though to see exactly what comes with each one. But it's pretty robust even on the standard one. But again, ultimate is the best seller. The prices are all very close. All right, now I want to do a deep dive into some of the things that we just covered, like the analysis. So I've got 5 or 6 short demos here. I normally go through them live. I like the videos better, so I'm trying them out. So I'm going to go ahead and show about 5 of these that are only 2 minutes long. And what they do is dive into each one of the things that we have already talked about, visualization and simulation, in a little different way though. And again, it's more like a demo so you can actually really see how it works and what buttons you would press. And again, all these videos are available on YouTube and our website, so we'll review that at the very end. But I'll go ahead and start the one here on simulation.
Predict how your design will work under real-world conditions before it's built. Comprehensive motion simulation and stress analysis tools integrated directly in Autodesk Inventor professional software give you the power to optimize and validate product performance early in the design process. Use the simulation environment to define driving loads, friction characteristics, spring rates, and damping factors for the simulation. With joint characteristics derived directly from the assembly constraints, it's faster and easier than ever to set up and run your simulations. Comprehensive graphing tools allow you to investigate and understand the precise behavior of the design and reaction forces calculated during the simulation, enabling faster and more accurate finite element analysis, FEA, at both the part and assembly level. Better understanding of the operating performance of your design can help you optimize the strength and weight of your designs to minimize material usage, check designs for high stress concentrations and modify part geometry to meet safety factors, size motors and actuators to reduce energy consumption and operating costs, identify and reduce unwanted vibrations to improve product quality, design cams and grooved paths by specifying the motion of followers. By leveraging the accurate 3D digital prototype in Autodesk Inventor, you can easily test and evaluate different potential solutions to a wide range of engineering issues, helping you to make the best design decisions and avoid costly mistakes.
Now, one thing that I do in the demo that left out is the most favorite tool of all of us engineers, Excel. So we can take all the data that was collected in that last video, all that information, charts and everything, and stick it into Excel so that we can go on and do even more comprehensive studies or deliver that information or keep it or put it in a manual. So again, it's integrated with Microsoft Office real well. So now let's continue on kind of on that theme of analyzing and taking a look at parts. Here's another short demonstration.
Cloud-based optimization tools enable Autodesk Product Design Suite users to perform large-scale iterative analyses on numerous assembly configurations simultaneously. Because these simulations are cloud-based, local hardware is unburdened, and users can focus on various design tasks while simulations run in the background to completion.
So again, finite element analysis, which really takes a lot of time to do. But again, with the cloud-based stuff, you can run it on another computer if you'd like, but you can run it out in the cloud with the credits that you get with your software. So you can actually take advantage of someone else's CPU time and get it done out on the cloud while you're still working, the results come back usually within an hour or so, even large ones. So it's pretty quick to do. This also is kind of the analysis stuff, but it's kinematics, and all solid modelers have it, but this is going to show, this short demonstration is going to show the amount of information that you can get back out of the system once you set up the kinematics. So not only is it kinematics, but take a look at what you can do once you get it started.
Analysis tools included with Autodesk's Product Design Suite enable users to perform motion analysis of their designs, reducing or eliminating the need for physical prototypes. Resultant forces, which are determined by these analyses, can then be used and applied to subassemblies and components, and those parts can then be tested to evaluate their performance during normal operation.
All right, so again, not your traditional just kinematics. What's nice about that is the analysis that you can get back from it. So also, something that I don't think gets used a lot is us in the tooling industry when we're building plastic parts. We have the part, but Inventor also includes the ability to do the die right from it. So it's a lot faster, and also analyzing how parts are flowing, or the plastic and material are flowing within the die. So at any rate, we'll play this one again, kind of a short one. It doesn't cover everything, but it'll give you an idea of how easy it is to generate a tool from your part.
Autodesk Inventor tooling software automates key aspects of the design of injection molds for plastic parts, helping you to quickly create and validate complete mold designs. Inventor gives you the ability to graphically display air traps and weld lines overlaid on the results from your mold flow analyses. Gain a better understanding of the impact of your design decisions. By displaying air trap and weld line indicators directly in conjunction with simulation results, Inventor gives a clear indication of the underlying causes of problems with the mold. Inventor introduces mold-specific functionality to increase the robustness of core and cavity creation with context-sensitive error checking and reporting. You will be able to automatically generate the core and cavity for a broader range of parts, whether native Inventor or imported files. Inventor 2011 supports working with unique core and cavity, insert, and core pin instances in pattern. This allows for instance-specific detailing of mold aspects, such as gates, runners, and cooling channels, helping engineers to create more realistic patterns. Quickly evaluate the range of motion for the opening, closing, and ejection stages of your mold base assembly. With Inventor, you can now dynamically simulate the motion of your mold base assembly to easily examine the mold base components for clearance and interference.
So what's great there is, it's doing most of all the design work for you, all the tedious stuff. It's really done a great job automatically generating the upper and the lower, or your cavities. It's up to you to just get in there and kind of finish up the details, something that a computer, a lot of the software generally isn't very good at. So, again, that's a real powerful tool. It also is inherent in frame builder, sheet metal, so not just dies. So you can also do stampings too. This one here shows how to minimize some mistakes and bring in a lot of data. So not just some of the discrete parts, but actually looking at a lot of data. So we'll take a quick look at this video.
It is often necessary to place your digital prototype into a much larger digital mock-up. The Autodesk Product Design Suite utilizes Autodesk Navisworks to accommodate models of incredible size, consisting of thousands or millions of individual parts. In this scenario, a large front loader design is just a small part of the digital mock-up of a fabrication facility. Navisworks allows designers to combine 3D models from many different CAD sources to a single digital environment. The size of the Navisworks environment goes beyond the capability and capacity of most CAD authoring systems. You can explore the digital mockup using real-time fly-through and walk-through commands. This capability allows you to experience the digital design long before actual fabrication or construction begins. Redline markup and clash detection tools are also available, allowing you to easily discover interferences and notify all members of your collaborative team. The Autodesk Product Design Suite is equipped to accommodate large detailed designs like the front loader, but it is important to note that it can also easily display the entire front loader fabrication facility if required.
Some other great uses for that is the fact that I work with a company out west that actually uses it for packaging. So they take their very large assembly, which happens to be compression units, either for gas or electricity, and they're used on such things as oil rigs or out, in remote areas. But how do you get them there? So they can actually package them on the train or the ship and see how they're going to be loaded and fit in with just a scan and or, somebody might have a detail of the ship already. So again, they're quite large models. Also installation, how do you actually use a helicopter and get it to the oil rig, on the oil rig, and then how do you install it where it needs to be in the oil rig? So moving it through the oil rig and seeing all the potential pinch points and or collisions that you might have is a lot easier. So again, it's a real good package. It's called Navisworks, and it allows for just massive files to be displayed, all the parts in at one time. And again, they can be 2D, 3D, scans, drawings, different CAD systems. So anything can go into Autodesk Manage and Navisworks. Let's take another quick look at how we track changes. And again, this is more data management. Any data management can be used, but some of it actually comes with this package. And here's a quick demonstration of that. So what we're doing is we're taking unlike parts from different CAD systems, and we just drag and drop them in. So instead of doing translations, it makes it a lot easier. You can take all different pieces, and as we talked about packaging, how am I going to get it there? So this being Navisworks, I can drag all these different parts on and show how the truck would hook up, what are all the weights, the loads, what are the balances, and stick them all on a truck at one time. So again, it's just getting all the pieces there, and then what order do they go on the truck, and what order do they come off the truck? So there's quite a bit to getting something somewhere. Also distances, do you have interferences, and are you documenting all that? The guy who's loading it, is he going to get any information back that, hey, I need to have so much of a gap because the truck and these parts can move on it as it's being shipped. So again, that's important to limit or help reduce damage once the assemblies get there. Also, any other types of notes and stuff can be applied. Here, they're taking a more detailed look at what's in it and creating planes to stack all these parts together. So I believe in this one here, this was a purchased rack, and they're showing how their parts fit in a purchased rack. So again, all these systems come from somewhere else. So again, just a quick demonstration on just transporting parts. We often don't really think about that as engineers. We design something, and is it too heavy to fit on the truck? Does it fit on the truck? There was such thing as a car that was designed here in AMC Motors, the Pacer, way back in the day. If anyone remembers that, I'm dating myself. And everyone called it the pregnant roller skates because it was so wide. But the funny thing about it is it didn't fit on a standard train car. It couldn't be transported anywhere. So here you got a large assembly that couldn't get to the end user, so kind of funny. Help win more business. Let's take a look at this one. This is also kind of a good video on doing the visualization and presenting your design of your product, whether it's internal or external to other customers.
The Autodesk Product Design Suite this year is the ability to automatically create various rendering types and styles in Showcase. Here, an assembly is imported into Showcase and then displayed in a photorealistic environment utilizing mechanical configurations and material alternates, as well as animated behaviors which were defined in Inventor itself.
Big question on that one is, what's photorealistic? Well, photorealistic is photorealistic. Everybody wondered, when are they going to come to the day where I can render something and I can't tell the difference between it and the photo? And that day is here. They've had professionals look at these things laid next to each other, photos in the computer along with the rendering, and then printed copies out on a desk. And it is incredibly hard, if not almost impossible now, to tell the difference between what is a photograph and what has been generated from a computer. So if you have a website you're keeping up that you're putting products on, it's brochures. It's a great way to go. You don't have to have a mock-up or a real model to take photographs of. It can actually be done from the computer. Also reducing rework and looking at drafting. So let's look at a couple of these videos. Again, they're quick.
Users of Autodesk's Product Design Suite have the option of using AutoCAD Mechanical for the creation of their production drawings as an alternative to Inventor's Drawing Manager environment. This workflow has several advantages, not the least of which is the ability to leverage AutoCAD, the industry standard drafting tool, and the large base of users familiar with that tool. Drawing environment setup is quick and easy, and facilitated by a library of predefined standard drawing templates. Once the drawing environment is set up, the Inventor model is imported, and then views are created using an almost identical workflow to Inventor's Drawing Manager. A base view is placed, and then projected orthographic and isometric views are created and arranged on the drawing sheet. As with Inventor's Drawing Manager, views may be shown with hidden lines displayed or suppressed. Section and detail views are also supported, and again, the technique used for their creation mirrors that used in Inventor's Drawing Manager. Dimension types and styles are standard driven, defined by the drawing template used initially to set up the drawing environment. This cross-product workflow enables automatic drawing updates subsequent to a change to the model. Here, a change to the diameter of this hole from 10 to 8 millimeters is made and then saved. The next time the AutoCAD production drawing is opened, the user is notified that a model change has been detected and that the drawing views need to be updated, all of which is done automatically with a single user input at this prompt.
So again, using Inventor's drawing package, or going ahead and using something that you may be more familiar with, like AutoCAD. So you have AutoCAD Mechanical that comes with it, and Electrical, which we're just about to cover. So all those packages allow you to do your drafting in a style that you may be more used to if you were an AutoCAD user prior to coming into the 3D world. So it's a very useful tool. You still get that relationship bidirectional with both products. It's just the note that you get that says that you have to update it. It can be set to be automatic if you're in Inventor. This is another product optimization that's really nice. This really helps production. This is routing, so it's not just electrical. So this is going to concentrate on that, but you can do tubes, pipes, anything. Think about even a factory running all this stuff through and finding areas where it goes through, and then getting an Excel spreadsheet or bill of materials back and to where they went, what they come out as. So here we'll take a look at mostly AutoCAD Electrical and how it's integrated with Inventor and Design Suite. Again, another package that comes with it. So let's take a look at this video.
For users of Autodesk's Product Design Suite who need schematic support, AutoCAD Electrical can be used to create any type of point-to-point document, shown here in the creation of a wire harness. Harness data can then be imported into Inventor Professional along with reference designations for both wires and connectors, and then used to automatically generate 3D cable harness designs.
So what's nice about that is you notice that what it did is it just shot a straight line from one area to another. And it's the same thing with the tube, rubber hoses, or all those different types. So I can actually know point A to point B, and then I can physically route myself as a designer how that tube is going to fit in there, and the bends, or whether it's a harness, where I'm going to put wire ties, where I might screw it to the side and support it, whether I need to put heat guards on it. So at one point in time, you're designing the schematic, an electrician, and at the other point in time, you're installing this harness into a product. So it integrates that process, so it makes it a lot easier. And just to kind of review and cover some of the stuff that was an Inventor. I know we covered a lot of data, so hopefully you have a lot of questions. Autodesk Inventor itself is really kind of the core product in there. And again, design, visualize, and simulate. So we're going to dive in just a little bit more detail on what's an Inventor Professional is what I'm showing here. Again, version 2014. So again, this really concentrates on the design and the visualization and the simulation of what's in here. But it uses different analogies, and we have some different parts. So as you can see, with design production, you can carry anything in. If you look at the top picture up here, parts that are from other systems. We can do animation along with the automation of putting it on an assembly line, and make drawings and documentation. Also, the simulation really is second to none. It's just amazing now what computers in general, especially Inventor and Showcase, can put out. So you really have a hard time distinguishing whether it's an image generated from the computer or if it was done from a photograph. So and just in Inventor, even that portion is really good. But with Product Design Suite, it adds Showcase, which even brings in a lot of lighting and different aspects into it. Integrated data management, do you have to use it? No, it's there, it's free. Most people do use it. It can hook to other systems if you're running something like Team Center or some other existing PLM system that's there. It can hook right to it. Ford uses it, even though they're a Team Center user. So it's something that can help you manage your parts in your work group and then take it to the corporate-wide PLM system. So the other thing we talked about was just the productivity, and I think I kind of covered this, but getting from 2D to 3D has really become a lot easier. It really is easy to use. I mean, if you go through Inventor, the buttons are simple. It's in a ribbon now. It's very intuitive, and anyone that's had any kind of experience on a computer can pick it up pretty quick. Most training is done from the web now. Also, if you take a look at it, to get started, if you hover your cursor over any one button, it explains to you what that button is. If you leave it there long enough, it shows you a quick animation of what that does and how to do it. So again, even if you haven't used, say, like sheet metal in a long time, all you have to do is hover your button over it, and it'll teach you how to do it. So a very intuitive, easy to use program. There's a couple of nice features that was put into 2014. One of them is with solid modelers. Everybody knows we have to orient the part in the right way. You know, the surface has to be against the other surface, and the holes and everything else. Now it's literally two picks. If you're trying to put some type of stud into a hole, you just pick the two, and it automatically moves the part over and sets it on it. So in the example of this ring, pick the center of the ring, pick the piece that it's supposed to fit on, and it just orients it automatically. So and you pick on the side that you want, obviously. But again, this was two picks: the stud, and the part that it was going to fit into. So putting a screw in a hole or a bolt is just two picks now. It's much easier than what it used to be on any solid modeler. So that makes life a lot faster. Here too, looking at large assemblies, people were complaining a little bit on their existing hardware. It just wasn't working well. So Inventor has been optimized now to run on the hardware along with the graphics board, the complete throughput. So assemblies load much quicker, a lot faster. Autodesk has claimed 5 to 10, but everybody is seeing a lot more than that. So large assemblies are easy to load now, and that's important because we all know the joke. What do you do as soon as you hit load? You go get a coffee, and that's not the case now. It actually loads very quickly. Another thing is standard parts. Everybody had libraries, but what you really want to do in your assembly is put the part in that you're purchasing it from. So here's the vendor, Parker, and we're going to purchase this part from Parker. So now when we do a bill of materials, we actually have the right part number that we're going to order. All the specs are there, the weights and everything. So when you do analysis, you don't have to guess at anything. So you don't use a standard library. You use the part that you're actually purchasing to put in your system. And of course, you can add your own parts to this too. But it's much more than just a list of standard libraries anymore, and that really keeps things fast. And it allows for things like FEA and bill of materials to work a lot easier when you do it that way. I talked a lot about the visualization, I think because I'm really enamored by it, so I apologize. But again, it's just second to none. Autodesk has always been a leader when it comes to visualization after they purchased the company with Maya. So, I mean, if you take a look at Avatar, that was done on all Autodesk software. So when you get to animations and gaming and bringing that into Inventor in our mechanical engineering world, it really gives us a lot of tools that we didn't have before. So visualization and animation is just special now inside of Inventor, and it wasn't before. Reuse. I mean, we talk about, well, you know, even back just 5 years ago, well, can you read an IGES file? Can you do this? Yeah, there's just no more questions about that anymore. So, and a lot of people don't even think it's a translator because it's basically drag and drop. So you can see a short list of all the different files that Inventor can just seamlessly grab. You could drag it in and drop it into your model and then start using it. So there's not, you know, it is a translator, but there's not this kind of translation mentality anyhow. You just grab parts, drag them in, and use them. So it makes things a little bit quicker. Interoperability seems to be a question, not only, you know, amongst other CAD systems that we just talked about, but even in the Autodesk world. Everybody's getting into BIM now. You know, you have to get your material or the parts that you guys build or engineer over to the building or inside the car. And what's it look like when it gets over there? Well, it should look like the way you designed it, as you can see on the left. So over here, we have a complete design that I could actually manufacture. Every hole, every nut, every bolt, all the pipes, all the fasteners, everything is in there. But if I want to stick it in a very large model, what I really want is, you know, a scaled down version of it. I don't need any of the internal parts. You know, I may not need any of the holes or fastenings. So you decide, using this menu up here, how you're going to shrink wrap this, if you will, and what level of detail that you want. And level of detail is actually defined now on the web. So you can conform to that standard. So if somebody says, yes, we're putting your air conditioning units on our building, but we want those delivered to us full, you know, the entire design, and we also want a level 1 detail so we can just plop it into our building assembly. So it has the ability to put pieces out that other people are looking for, such as Revit users or other systems that might drop buildings or large trains. I think one of the videos talked about this. It's kind of a big thing with 2014, the ability to use either system for drafting, AutoCAD straight out of the box, you know, or in Product Design Suite, or the drafting system that's provided inside of Inventor. Both are great. Autodesk's AutoCAD, obviously been around for a long time, a standard. Most people know how to use it. They're comfortable with it. They're fast. So a lot of people just prefer to use AutoCAD. So you can use either now as you're documenting from the solid modeler. That's true with any of the parts or assemblies and stuff in other things like Revit within Autodesk. They can all be put inside of AutoCAD now, which again is just, it's been around for over 30 years, so a lot of people find it easier to work right inside of AutoCAD. Simulation I think we covered, but we didn't go over in detail what simulation meant, and that is the motion, we saw that, but frame analysis and true finite element analysis, and then also the injection of the material into plastic parts. You can actually see the flow into your part, so you can analyze whether it's filling well or not. Is the part too big? When it cools, will it warp? So it has all that intelligence in it now, so when you fill a plastic part, you can see if it's going to have any type of cooling issues where it causes defects on the outside surface because of strengthening beads or ribs that you've added, and it'll also tell you whether the part's going to warp or not. So a great tool. Rather than find that out after you've built a couple prototypes, it's nice to find it out before you've even put it out to a die. So again, the plastic injection molding, there's just a lot there. And as you've seen in the demonstration, you can develop the upper and lower die or the cores right from the part now, whether you've built it or you drag it in from a competitor like, for us anyhow, like CATIA or SolidWorks. This is something that we didn't cover, but it's kind of a hot spot for everybody, is just how user-friendly or environmentally friendly is my part. When I'm done with it, can it be recycled? What do I have to do that? It's really heavy in automotive. It was, and it still is. The fact that you have to end the life a car. So when you end the life your part, what cost on the economy does that have in terms of recycling it and the environment? So this is kind of a nice eco-impact dashboard that you get as you're designing. So it's becoming more important to companies, and it's just a nice feature that's in there. The complete design, again, we talked about that, but Inventor Professional, even without Product Design Suite, really has a lot of stuff in it that you can use. The harness and cable development, tube and pipe, frame generator, the sheet metal, plastic part design, the injection molding that I talked about, all of that is included, and it really allows you to engineer the part, see fluid flowing through, see what impact heat and cold have on it before you get it out. You can even blow air over it to get an idea, if that's necessary, of how air will impact your part. And it's important when you're putting a fan in. Does the air that the fan's pulling in reach way back in the computer and cool all the parts or inside your machine? So it's just great stuff. It's information that can be stuck in a spreadsheet or put in a visualization package, so you can show somebody to say, yes, this is indeed, I checked it, this is indeed, this fan in this location is cooling our whole part. So again, just a lot of these decisions that we made by kind of carnal knowledge, you can actually test out to see if it's really true or not. Digital prototyping is still a big thing. That's really basically what I just talked about. Can I do it in the computer? All the things that we have to do. Can I visualize it? Can I simulate it? Can I prove it out? Can I document it? How do I do that all in the computer? I don't want to make a physical prototype. We can also read directly to a 3D machine so that you can print directly on a 3D printer. You can also take it out to CNC and make your models quickly. But a lot of people don't want to waste that time. They really want to get as much information out of the model inside the computer before having to make a prototype. So digital prototyping, that kind of thought process when developing Inventor, helped people stay in the computer longer and get answers back.